Hi everyone, this is Whit from Brainstem Tutoring, and in this video we want to talk about formal charge. Formal charge is something unique to every atom within a structure. Each atom, the three oxygens and the nitrogen in nitrate, have their own formal charge. Formal charge is a formula that you can use. Most textbooks have a more sophisticated way of saying it, but the way I find that my students enjoy or have it click is where I say that the formal charge of an atom is equal to how many valence electrons it originally had minus how many bonds touching it minus how many dots touching it. The bonds represent bonding electrons, and you really take the number of bonding electrons and divide by 2, but that's essentially counting up how many bonds there are. And the dots is a simpler term for just saying those unpaired or unbonded electrons. So we're going to move through this one slowly. Let's talk about nitrate. Oh, another tip about formal charge. If this structure is correct and valid, aka the right number of valence electrons, the sum of formal charges will equal the overall charge of molecule or ion. So nitrate has a -1 charge. So when we're all said and done with assigning the formal charges, they should all add up to -1. All right, so let's start with this northern oxygen, is what I'd call that. For this northern oxygen, we have formal charge is equal to 6 valence electrons. I'm not talking about its full octet. I'm talking about valence electrons from the periodic table. Minus 2 bonds coming off of it, minus 4 dots. So this oxygen has a formal charge of 0. We'll talk about this more in a future video, but atoms like to have a formal charge of 0. That's their preferred home, All right, let's talk about this nitrogen. The formal charge of this nitrogen is 5 valence electrons minus 4 bonds minus 0 dots, for a total formal charge of +1. All right, these oxygens, the southwest and the southeast, are kind of mirrors of each other. Formal charge of this bottom left oxygen is going to be 6 minus 1 bond minus 6 dots for a total formal charge of -1. And same thing over here, formal charge will equal 6 minus 1 minus 6 for a formal charge of -1. If you add up these formal charges, 0 plus 1 minus 1 minus 1 is equal to -1. And that's the overall charge of a nitrate. It kind of helps us reassure us that that was correct. Cool. I just have a couple more examples to go through to help drive this home. Sulfate is a funny example of an expanded octet. It's allowed to have an expanded octet because sulfur is in the middle and it's on the third row below the periodic table. Sulfur has an expanded octet in order to minimize its formal charges. Remember how I said that sulfur or atoms like to have a near 0 formal charge as possible? With 6 bonds, sulfur will have a formal charge of 0. But let's prove that. This sulfur, and we'll go a little bit quicker, has 6 valence electrons minus 6 bonds minus 0 dots for a formal charge of 0. This oxygen has 6 valence electrons minus 4 dots minus 2 bonds for a formal charge of 0. The southern oxygen is going to be just a mirror image, is 6 minus 4 minus 2 for a formal charge of 0. Now the oxygen on the left and the oxygen on the right are a little bit different. 6 valence electrons minus 1 bond minus 6 dots for a formal charge of -1. And the same thing on the oxygen on the right. For a sum of formal charges of -2. And that perfectly matches the charge of sulfate. One last example of a non-ion would be this molecule, formaldehyde. Let's start with the northern oxygen. 6 valence electrons from the periodic table, minus 2 bonds, minus 4 dots for a formal charge of 0. Carbon has 4 valence electrons, minus 4 bonds, minus 0 dots for a formal charge of 0. Hydrogen has 1 valence electron, minus 1 bond, minus 0 dots for a formal charge of 0. And this hydrogen is the same thing, 1 valence electron, minus 1 bond, minus 1 dot, or minus 0 dots for a formal charge of 0. This structure is super stable because it has all zeros. It's preferred state. And 0 plus 0 plus 0 has a neutral overall charge, which is how this structure or how this molecule is written. Wonderful. I hope this clears up formal charge and how to calculate formal charge. In a future video, we'll talk about how to use formal charges to judge which resonance structure is the best. If you have any questions, leave a comment or email us, and good luck studying.